In this first exercise, we've been asked to write a setup function that will initialize the timer. And we want to generate an interrupt every 35 milliseconds, and we're assuming we have a 1 megahertz clock that we're actually dealing with here. So let's start by writing our initialization function. We say void, we'll call it init timer because it's initializing the timer. And we're not passing any parameters or anything to it. So, okay. Now we know our clock is 1 megahertz. So CLK. Therefore, with 1 megahertz clock, we have each cycle of our timer is 1 microsecond. We want our period to be 35 milliseconds. 35 milliseconds needs to be the number of counts that we'll be doing. So we'll need to do 35,000 counts of our timer because 35,000 times 1 microsecond equals 35 milliseconds. So the mode that we're going to be using is up mode, and in up mode we're essentially counting up until we hit the TACCR0 value. Then we count up and hit that value and count and go back down again. So this value here is our TA1 or 0 CC 0. So let's implement that. TA will use timer 0 in this case. 0 CCR0 is equal to 35,000. We then need to set up a few other things. So we'll be using the SM clock and we'll be using up mode. So with those two, we need to look at our TACTL, our timer control register, and we'll be using SM clock. So we need to set those bits to 1, 0, bits 9 and 8. We won't be using a clock divider because we actually want the 1 megahertz. And we will be using up mode, so bits 5 and 4 need to reflect up mode down there. So TA0 CTL is equal to 0x. If we wrote in hex, it would be 0210. If we specify that in our shorthand that we've been writing thus far, we'd say it's bit 9 or bit 4. So we'll just put some comments there. Up mode. And SM clock. SM clock. Next, we need to enable the interrupts and make this thing actually interrupt. So if we go to the other register, the TA, in this case 0 CCTL0 register that we'll be looking at, we're not really too fussed about outputs and things like that. That doesn't really matter to us. But the thing that we are fussed about, which is in the lower bits, bit 4 in particular, is we need to enable interrupts. So interrupt enable bit 4. So we say TA0 CCTL0 equals bit 4. And then if we actually want interrupts to run, we need to enable them globally as well. So we say eint, and that will enable global interrupts for our device. Okay, our next question, we're writing the interrupt service routine from the previous one. So our interrupt service routines in MSP430, they always start with a hash pragma. We specify the vector, and in this case we're using timer 0. So we say timer A0 vector. So that connects it to the right vector. We then need to actually write the interrupt. No return value and no parameter that we pass to it. We'll give it a name, timer interrupt service routine, or ISR. We don't pass any parameters to it. Okay, then we need to say we want to check the value of P1.3. If it's high, set that pin high. If it's low, then set that pin low. So this is very easy, similar to the sorts of things we've been doing before. We say if 0 is equal to P1 in, and bit 3 is the one that we're checking. We want to set P2 out. In this case, we're going to clear it. We want it low. We want bit 4. Else P2 out. We want to set it now. And we want to set it as bit 4. There we go. We've got our nice little interrupt service routine. Our final question here, we're actually going to use a timer not to generate an interrupt, but to toggle or change the position of a pin. And so we should have enough information here to do it for us. We'll be using timer 0. We're going to be generating a square wave on pin 4. Which is P1.2. We need to have a period of 50 milliseconds and a duty cycle of 40% on, 60% off, and we've still got that 1 megahertz clock that we had previously. So let's write some code to set all this one up. Okay, let's start with the basics. We need to first set this pin as an output. So P1 dir equals bit 2, or equals bit 2, so we'll set it high, and we want to enable the special function of this pin, which will connect it to the timer. So we say P1 SEL, so P1 selects a special function, and once again we want to say bit 2. So now we'll be using the special function, the timer function of this. So the mode we're going to use is the up-down mode. And in the up-down mode, the TA-CCR0 register, so TA0-CCR0, that holds half of the total period value. So our total period value is 50 milliseconds. We want 25 milliseconds. So we put in 25,000 because we've got 1 microsecond clock cycles, 1 megahertz clock. So I'll just put a comment there. Half of PWM period, 25 milliseconds. Now this is of course because the timer counts up to our value in TA0-CCR0 and then counts back down again and counts up and counts down again. Now we want to specify the off time. and we can calculate our off time. Off time is equal to 50 milliseconds times 0.6 or 60%. That's equal to 30 milliseconds. So we want 30 milliseconds of off time. Once again, we need to halve that because we're using the up-down mode, and we'll put that in the TA0CCR1 register. So TA0CCR1 is equal to 15,000, 15 milliseconds. Now the reason we're using TA0CCR1 for our comparison register is in the question we've been told that we want to toggle a pin on P1.2, and having a look here at P1.2, we note that it's connected also to TA0.1. Now, TA0.1 indicates timer 0, comparison register 1. Hence we want to be able to use our TA0CCR1 as our comparison register to actually toggle this particular bit. Okay, now we need to set up our outputs, and we need to set up an output so it's connected to this particular register and does something for that particular register. So we're going to be using the toggle set mode on the output. So TA0CCTL1, because we're using this register here, is equal to 0x00C0. So we're using this register, the TA0CCTL1 register in this case, because we're interested in that particular compare. And we're using down here the toggle set output. So 1, 1. Okay, final thing is we need to connect up our clock and set it in the up-down mode. The way we do that is in the TA0 CTL or control register. Now we're going to set that as 0x0230. What that's going to do is enable the SM clock, and it's going to enable up-down mode. Now, as soon as we run that line of code, this time will start running and the output will start being generated.